Okie dokie, let's get busy with video number 3. Now, ladies and gentlemen, you've taken a few notes from the distance on the distance formula from the key idea at the bottom of page 658. What I'm going to ask you to do now is put your pencil down, put your pen down, put your markers down, take your eyes and your ears and your participation and put them right on me and pay attention and listen. When I am done, I will tell you, and then you can pause the video, pick up your pencil, your pen, your marker, your crayons, whatever you're using, and write down any additional notes onto your insert that you think are helpful for you, and then we will pick up from there. I'm going to be spending a little bit longer time on this page, and this video will be a tiny bit longer than the other two. I'm sorry, it's the way it is. But this distance formula is challenging when looking at it, but really it's quite easy. It's quite easy, especially if you understand Pythagorean Theorem. All right? So, put your pencils down, pay attention, listen up. All right? So, ladies and gentlemen, it says the distance formula, or the distance d, between any 2 points, x1, y1, and x2, y2, is given by the formula that the distance is equal to the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. And then they gave you this funky, well, not funky, but they gave you this nice little picture, and they're expecting you to understand it. Well, it really is easy to understand because they're giving you a picture of what? This is a right triangle, all right? And what they're saying is the distance between the 2 points, that is the hypotenuse. So they've taken C and turning it into D. That's what they've done. And they've taken the horizontal distance between the two x values, and they've subtracted them to find that distance, and they've squared it. And then they've taken the two verticals, the y2 and the y1, they've subtracted that to find that distance to get you this one. So really, this is B, this is A, and it doesn't matter which one you put where. Please understand they're interchangeable. And so now why did they get it looking like this? Why is it not the distance squared is equal to x2 minus x1 squared plus y2 minus y1? Because they're trying to simplify it out. In other words, they took c squared equals a squared plus b squared. They took c and made it d. And then they took the square root of both sides. And well, what's the square root of d squared? That's right, it's d. Well, they left this square root symbol on this one, and then they said a was x2 minus x1. And they're squaring that because we're squaring a. And then we're adding. And then they said b was y2 minus y1. The distance between any 2 points anywhere, you subtract to find the distance between any 2 points anywhere, right? So that's all they've done. That's it. This is A, and this is B, and this is Pythagorean Theorem. No one ever told me that in school. I couldn't believe they never told me that the distance formula is nothing more than Pythagorean Theorem. I probably should have figured it out on my own. I didn't, because I was too concerned. They also told me this other thing. I'm going to help you out, because you are going to see and hear distance formula again in algebra and in geometry. So they told me the 4 S's. They told me the 4 S's. They said you subtract, because I have to take x2 minus x1, and I have to take y2 minus y1. And then you take the square, because then I'm going to square them. And then you take the sum, because I'm going to add those two values together. And then you take the square root. So in high school, my high school teacher taught me the 4 S's when I was a freshman. Taught me the 4 S's. Subtract, square, sum, and square root for Pythagorean Theorem. All right, which is nothing more than a distance formula written in a funky looking, challenging way. So hopefully I made this a little bit more understanding for you, that the distance formula is nothing more than Pythagorean Theorem. And all they did was relabel A, B, and C in a different way. So let's do it a couple times. On the first one, I am actually going to do it 2 ways. I'm going to actually do it 2 ways. And the first way is going to be using the distance formula. And we know the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And now we're just going to plug in the information. Well, the x's, we have x1 here, we have y1 there, we have x2 here, and we have y2 there. It doesn't matter which one is which. That's just how I know it, numbered it. And so I'm going to say x2, that's negative 5. Why did I do that? That's negative 5. I don't need a comma there. Negative 5 minus negative 2. And I'm going to take that value and square it. And then I'm plugging in the y's. Well, y2 is 1 minus y1 is negative 3. And I'm going to square that. These get added together, and I'm going to take the square root of the whole thing. So that's what the distance is equal to. Now I'm going to start my 4 S's. The first one is subtract. Negative 5 minus 2, negative 2 gives me negative 3. Right? Adding to that, well, 1 minus a negative 3 is 4. Okay. And then I'm going to square. This is my second S. I'm going to square. So negative 3 squared is 9. And I'm going to add that to 4 squared, which is 16. And then I'm going to find the sum. 9 plus 16 is 25. Right? And now the square root of 25, the distance is 5. Right? So that's how they want you to do it in the book, using the distance formula. Well, I think it's a lot easier using Pythagorean theorem, so I'm going to do it this way. Over here, a squared plus b squared equals c squared. The only difference is I am going to find a because I'm going to take the 2 x's, and all I do is go like this. To find my first value, I connect the 2, and I say negative 2 minus a negative 5. I didn't write that very well, but that's what and then I'm going to square that, plus I have negative 3 minus 1. And I'm going to square that. Well, negative 2 minus a negative 5 gives me 3. And negative 3 minus 1 gives me negative 4. Notice, these are exactly opposite from what we did in the distance formula. It makes no difference. We're going to get the same answer. And now we know this is equal to c squared. Well, 3 squared is 9, 4 squared is 16, 25 equals c squared. Take the square root and c, or the distance, is 5. All right, moving along. I'm going to do this one using the distance formula only. I'm going to do the next one using my way. And then you're going to figure out which one you like the best. So the distance formula says take the square root of x2 minus x1 and square that, plus y2 minus y1 and square that. Right? And then we label the points. x1, y1, x2, y2. We plug in the information, and we say that x2 is 3 minus x1 is a negative 3. And we're going to take that and square it. Add that to y2. y2, which is 1, minus y1 is a negative 1. And we're going to square that. And now we're doing the 4 S's. Subtract. 3 minus a negative 3 is 6. And 1 minus a negative 1 is 2. 6 squared, we're going to do the square, is 36. 2 squared is 4. Now we're going to do the sum. That's 40. Now we're going to do the square root of 40. And the square root of 40, ends up to be, what is it, 6.3. The square root of 40 is 6.3. So some people like that, because once they learn it, they understand it, they know it, they do it. It's nothing more than Pythagorean theorem. I'm going to do one last example. We'll be done with these videos. Ladies and gentlemen, so now I'm going to take my a squared plus b squared equals c squared, and I'm going to say this is a. 2 minus 4, and square it. That's what I did. I took those numbers right there, I connected them, that's my a. My b, I'll even put a there and put b here. B is 5 minus 1. No negative numbers in here, so we're looking out pretty good when we're doing the subtraction, so we don't have to worry about those integer rules. Well, 2 minus 4 is negative 2 squared. 5 minus 1 is 4 squared. And we know this is always equal to our hypotenuse squared. And negative 2 squared is 4. And 4 squared is 16. And that's equal to c squared. 20 is equal to c squared. And then we take the square root of 20 to get c. And we say 4.47, which we'll round to the nearest tenth and say 4.5 is equal to our distance, c. So whatever works best for you. The one doesn't really cut down any information more than the other. I just kind of like being able to draw this little connection between the A's and the B's and just do the math and keep it in Pythagorean's theorem. But to do that, you have to understand that the distance formula is Pythagorean's theorem. So we're going to our last quick write. Find the distance between these 2 points, round to the nearest tenth. As you're writing those points down, listen to me as I say. Please come to class with questions regarding using Pythagorean theorem. The uses of Pythagorean, specifically, most likely, the distance formula. Finish off your 45 minutes using your time effectively, quality effort with aggressiveness and urgency. Get it done. Come to class tomorrow with questions. Ladies and gentlemen, what can I say? It has been awesome this year. It has been absolutely awesome. I have enjoyed every minute of working with you. I know we're not quite done yet, so I don't have to start crying yet. I'll wait until the end of the year for that. Ladies and gentlemen, I will see you tomorrow. Have a great night and work those 45 minutes to your best ability. Thank you.